Section 11.5. This is verb again. Call text 720-985-1986. This is our second to last section, and I already lectured over this. So let's just find a good problem. 1 plus I radical 3. And of course, they're going to give me like a unit circle angle here. I'd like to take this to the eighth. Well, I don't like the x plus iy form, so I'd like it to convert it to RCIS theta. So the radius is always the square root of x squared plus y squared, which is the square root of 1 squared plus the square root of 3 squared, which is the square root of 4, which is 2. So 2 CIS theta ref, which is actually theta, because x is positive and y is positive. If we were to plot this complex number in the real and the imaginary plane, we get over 1 up the square root of 3, and we just plotted a number, plotted a point in an imaginary world. Now we pretend there's imaginary radius and imaginary angle, and we're going to find this angle by inverse tangent of y over x, which is inverse tangent of the square root of 3 over 1, which you should know by memorizing in the circle is 60 degrees. So CIS, the theta is 60 to the eighth. Now the formula that you were given, I gotta move this down here because I run out of room, is 2 to the eighth CIS to the 8 times 60. Because there's no way I'm gonna multiply that out. And 2 to the fourth and 2 to the fourth is 16 times 16, 256. CIS 480. But 480 degrees is the same, you subtract 360 and it's 120. So 256 CIS 120, which is 256 cosine 120 plus I sine 120. 256 cosine of 60 is like cosine of 120. Cosine of 60 is 1/2, but it's negative at 120. Sine is positive. Sine is like sine 60, square root of 3 over 2. Bring it. Pick up 128 negative plus 128, the square root of 3. Take any number, complex number to a power, and you can use that. All right, so the next one is kind of hard to explain. So let's see what we can do. So back in the day, if you had x squared equals 9, your answers are x equals plus or minus 3 via the square root method. If you have x squared equals 9 negative, by the square root method, x equals plus or minus 3i. So what are we doing? We're taking square roots. Now, if you got x cubed equals 27, you cube root both sides, the third root, and you get x equals 3. But what about the other two answers? Since you have x cubed, so basically it's like the polynomial x cubed minus 27. It has this polynomial has 3 zeros if complex is considered. It's just that we don't know what the two complex zeros are. Now, we know one real zero is 3, but what are the other two? Makes it kind of challenging. Now, we could take this and divide by the corresponding factor, but then we'd have to get into like long division or synthetic. It doesn't hurt to mention it. 1 for the cube, 0 for the square, 0 for the x, minus 27. And you divide by 3 because it's opposite the factor. And you get 1, and you get 3, and you get 3, and you get 9, and you get 9, and you get 27, and you get 0. It's this right here. When does that equal 0? Well, it doesn't factor, so let's do the b squared minus 4ac. We're going to apply the quadratic formula, and we get 9 minus 4 times 1 times 9, and we get negative 27, so that's 9 minus 36. So x equals negative 3 plus or minus the square root of negative 27 all over 2, which equals negative 3 plus or minus 3 square root of 3i over 2. And you can see that this actually has two imaginary solutions and one real solution. So there's a lot to explain there, right? Now, what we're going to do is learn how to take the cube root using a complex number. So basically take cube roots in the complex world. So here we go. So given let's say an equation like, well, no, first let's go given r CIS theta or x plus I y equals z. So a complex number. And what we're going to do is, let's write it down. If n is a positive real integer, so n is a number, is element of the natural numbers, which by the way are 1, 2, 3. R is positive real. R is an element of the real positive numbers. So 0 to infinity. And theta in degrees. Then z has exactly n distinct nth roots, and they are the nth root of r CIS alpha, such that, that's that symbol, such that alpha equals theta plus 360 k over n, which is really theta over n plus 360 k over n where k is the element of the whole numbers, which are 0, 1, 2, da 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 da. Okay, so let's try a few. Let's go this way. Let's let z equal negative 8 plus 8i square root of 3. Nobody likes x plus iy anymore. Let's go for convert it to CIS. Negative 8 squared plus 8 radical 3 squared equals square root 64 plus 64 times 3 equals the square root of 16. Oh no, it is 16. It's 256, which is 16. Angle theta, once again, what realm are you in? X is negative. You're in the second quadrant here. Because x is negative, y is positive. And I just do inverse tangent of the y value over the x value. I would never use a negative ever. And I know inverse tangent of the square root of 3 is 60 degrees. Therefore, this is 60. So therefore, that's a reference angle. Theta is 120 degrees. So we got z equals 16 CIS 120 instead. Now let's take the fourth root of z, which is the fourth root of 16 CIS 120. Well, first of all, we know the answers are alpha 120 plus 360k over 4 over 4, which equals 6030 plus 90k. So alpha sub 0, let k be 0. Here, let me write that down. Really spell it out. Alpha, where k equals 0, is 30. Alpha, where k equals 1, is, looking at 120. Keep adding 90. K equals 2, 210. Now, if there's the fourth root, there's exactly 4 solutions. So you go up to 3 degrees, degrees, degrees. And therefore, my answers are the fourth root of 16. First of all, that's 2. So it's 2 CIS 30, 2 CIS 120, 2 CIS 10, and 2 CIS 300. Ooh. Boom. Those are ugly. That's the fourth root of a complex number, and there's 4 answers. Crazy, huh? Now we could bust all those out, like go cosine 30 plus I sine 30, etc. I don't know if I want to, but it's going to end up being the square root of 3 plus 1i. It's going to be negative 1 plus I radical 3. It's going to be negative square root of 3 negative I. And it's going to be 1 minus I square root of 3, and that's just me being lazy and copying right out of the book. Now, what do we really use it for? Well, given x to the 5th minus 1 equals 0, and we got x to the 5th equals 1, and we know when we take the 5th root of both sides in the reals, we get x equals 1, but do not know the other 4. So don't work here. Work in the complex. Take the 5th root in the complex world. So what number are we talking about? We're talking about taking the 5th root of 1. What is the 5th root of 1? What is the 5th root of 1 plus 0i? Where am I? I am, x is 1, I am here. What is my angle? My angle is 0 degrees. What's my radius? My radius is 1. Convert this to the 5th root of 1 CIS 0 degrees. Now the 5th root in CIS notation, we just have formulas for that. The most important is that alpha equals the theta plus the 360k over 5 over 5, which equals, what's 360 divided by 5? 360 divided by 5, 360, 72? 72k, where k, 1, 2, 3, and 4 this time, because we know there's 5 answers. So alpha equals, let k be 0, 0 degrees. Alpha equals 72 degrees. Alpha equals 144 degrees. Alpha equals 216 degrees. Alpha equals 288 degrees. Now, we know that the solution is the nth root of r CIS alpha, which is the 5th root of 1 CIS 0, which by the way is 1 CIS 0 degrees, CIS 72 degrees, 1 and then you just convert them. For example, you'll get decimals. The first one is 1 cosine 0 degrees plus I sine 0 degrees. Cosine of 0 is 1 plus I sine of 0 is 0. We get 1. Told you 1 was an answer, but the rest all suck because it's 1 cosine 72 degrees plus I sine 72 degrees. Well, you get some decimal plus I sine decimal. It's going to be a complex number, and nobody's going to want to find those answers. But if you plot them, you know that it's on a circle of radius 1. And here's the first answer. 72 degrees later is the next 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 answer. So all these are 72 degrees apart. So I can see where they are in the real, in an imaginary plane. So this is the only truly real solution because it's 1 comma 0, it's real. The rest are actually complex and don't make any sense. So I don't know if you want to do that again. I don't know if I want to do that again. So I think I'm done. That's the end of that lecture. Only 20 minutes.